ABC, we are going to be diving into our advanced techniques of integration. So building upon our knowledge with our straight integration rules, then we also learned U-sub. Today we're going to be learning the new technique, and that is integration by parts. So when we learned U-substitution, why did we do it? Well, U-substitution is basically the reverse of chain rule. We're going to be learning integration by parts because this is going to be basically the reverse of our multiplication or product rule for derivatives. So let's think about if we are using our product rule. So let's say that I'm taking the derivative, that's what that d over dx stands for, of f of x times g of x. We know from product rule that we take the derivative of the first, we keep the second, and then we keep the first, take the derivative of the second, right? This is our product rule. So what I'm going to do is I'm going to begin this video by showing you how we can develop the formula that we're going to use for integration by parts, okay? So we're going to, instead of using this f of x and g of x, it's kind of a lot to write out, I'm going to replace those with u and v, okay? So u is f of x, g of x is v. So that means if I'm going to replace it over here, that f prime of x would be u prime, g of x would just be v, then we have f of x was our u, and g prime was our v prime, okay? So here is our product rule. All right, with u's and v's instead of f and g. So let's say that I want to integrate both sides. I want to find the antiderivatives. When I integrate the derivative of uv, I just end up with uv. Now here, I'm going to add an integral sign to each of these because right now I have multiplication, and remember, we don't know yet, you will learn in just a minute, how to integrate here. Okay, so here, what I'm going to do next is I'm going to, instead of leaving it like this, I'm actually going to solve for this integral right here, this right integral. So I have the integral of u times v prime, that's equal to uv minus, so I'm keeping it on this side, I'm just reversing sides, uv minus the integral of u prime v. All right, what I have here is the formula for integration by parts. But I'm just going to reverse this a little bit or change things up a little bit. Sometimes you'll see the formula written with these primes to signify the derivatives, but I like rewriting them with du or dv. So here's our formula. We have the antiderivative of u dv is equal to uv minus the antiderivative of v du. So I'm going to circle that. That is the formula that we are going to be using for integration by parts. One of the ways that I like to remember this, because it can be kind of confusing of what goes over here, I like to think ultraviolet voodoo. All right, reason for that, ultraviolet voodoo, it's like we're doing this intense, it's an advanced integration technique. So we're doing something crazy, and I don't know, voodoo is kind of crazy. So that's kind of how I like to remember it. Maybe it can help you. It also just rolls off the tongue nicely, right? uv minus v du. All right, so this is the formula that we're going to use. So I want to look at some examples, and we can see what is the actual process of doing integration by parts. So let's change colors here. Let's do example 1. Let's begin by finding the antiderivative of x e to the x dx. All right, so your first step is you want to identify your u and your dv. Okay, that's going to be your first step in integration by parts. Now, here's a couple of tips to think about what your u and dv are. We're essentially trying to get this integral that we have here to look like u dv. It's like we're doing u substitution in a way, right? We're building upon that knowledge that we have, but now instead of thinking u and du, we have u and dv, so they're unrelated, okay? When you're picking out your u and your dv, you want your u, when you pick your u, you want your du to be simpler. Okay, to be simpler. So think, for example, if you have x cubed, 3x squared is simpler than x cubed. Or think about if you have the natural log of x, right? 1 over x is easier to integrate, for example, than the natural log of x. For picking out your dv, you want your v to be, or you want to be able, let's say it this way. You want to actually be able to integrate your dv. So you have to know the antiderivative. Have to know the integral of dv. Okay, the antiderivative of dv. Okay, and your v will be simpler. Okay. And in class, I'll go over a nice little phrase that you can use to help you pick this out, but I want you to go through the problem solving process, there we go, before we go into the little shortcut tricks. Okay, so let's look at this first one. We have x e to the x dx. So my first step is I'm going to identify my u and my dv. So I'm going to switch colors here. Let's do this orange. So I like to write it either to the side or underneath, whatever you prefer to do. So I'm going to do it over here. I want to pick out my u and I want to pick out my dv. I usually start with picking out u and thinking, okay, I have x and e to the x. Which one, when I take the derivative of it, is going to be simpler? Well, when I take the derivative of x, I get 1 dx. That's simpler, right? When I take the derivative of e to the x, I get e to the x dx. So which one gave me a simpler answer? That would just be the x. So my u is x. Then to pick out your dv, you just write what is left. So I get rid of that x, I kind of erase that from my vision, and what do I have remaining? E to the x dx. Now when you're doing this, your second step is you need to find your du and your v, okay? So when we have du, I'm looking at what's the derivative of this u, that would be 1 dx. Then for dv, we're going to integrate to get to v. So what's the antiderivative of e to the x dx? That's just e to the x. Great. Now that we have these 4 items, we are ready to then plug it into our formula, okay? So I'm not going to rewrite my integral, but I'm just going to write underneath here an equal sign. So I have the antiderivative of x e to the x dx is equal to u times v. So x e to the x minus the antiderivative of v du. So e to the x times 1 dx. And I'm going to, instead of writing the 1, I'm just going to include that dx. Great. You have one more step then. You have one more antiderivative to find. And this one's really easy, right? We know e to the x, that's the easy one. So we have the antiderivative e to the x dx is just e to the x, and we add our plus c. Great. That's your first example. All right, let's see if we can do it again. All right. So example 2. My goal is to get through a few examples with you guys, and then in class we'll cover some more techniques as well. All right, let's say we have the natural log of x dx. Okay, now just thinking about the integration rules that we know, right? We always want to go through that process of, is this a rule? Did we ever learn the antiderivative of natural log x? No. We learned the derivative, but we never learned the antiderivative. Second step, u sub. If I did u sub, I'd pick the natural log of x to be my u. My du would be 1 over x. I don't have 1 over x anywhere. Can't use u substitution. So next we go to integration by parts. Okay. All right. So you might be thinking, well, what 2 functions do we have here? Or where's the multiplication? When you only have, so it looks like we only have 1 function with natural log x, but it's really natural log x times 1 dx. Okay, you can think of it that way. So we begin by finding our u and our dv. And kind of, I think I mentioned this one earlier, but thinking about the natural log of x, if we pick that to be the u, what's the derivative? 1 over x. That's a lot simpler. If I picked a natural log of x to be my dv, I don't know the antiderivative of natural log of x, so therefore it doesn't work. So our u would be ln x. Du, the derivative of natural log x, is 1 over x dx. So then our dv we look at what's remaining. So cover up that natural log x. What else do you have? 1 dx. What's the derivative of, or the antiderivative of 1 dx? It is just x. Great. All right, so we use our formula, ultraviolet voodoo. So UV, we have x times the natural log of x, I just switched it around, minus the antiderivative of ultraviolet voodoo. So V du would be x times 1 over x dx, which here you'll notice that this is going to simplify to 1 dx, and we integrate one more step. So we have x times the natural log of x minus x plus c. Ta-da. All right. Let's do another example. Example 3. All right. Let me pull up my notes for the problem I wanted to do. Let's continue x to the 6th natural log of x dx. All right. See if you can identify what your u and your dv are. All right, so thinking about this one, we have a power, an exponent here, and we have that natural log of x. We've used both of these as our u before. So maybe for this one, it's easier to think about dv. Out of x to the 6th, the natural log of x, which one of those can you integrate by hand? If we did natural log of x, we'd have to do integration by parts again. So we're going to let our dv be x to the 6th because I can integrate that just by looking at it. X to the 6th dx. And our u then is what remains the natural log of x. So we find our du, we find our v. The derivative of natural log x is 1 over x dx. What's the antiderivative of x to the 6th? It's x to the 7th. We add 1 in our exponent, divide by that new exponent. Okay. Ultraviolet voodoo. So we've got uv. That would be x to the 7th times the natural log of x, all divided by 7, minus voodoo. So the integral of v du. I'm going to bring out this 1 over 7 because that's a constant. So we have 1/7 times the antiderivative of x to the 7th over x dx. And look at that. Why is that nice? This became x to the 6th dx. So one last step. We've got x to the 7th times the natural log of x over 7 minus 1 over 7 times the antiderivative of x to the 6th, which we just found. So that was x to the 7th over 7 plus c. Perfect. I have one more example here. So the antiderivative of x squared sine of 4x dx. So we have some trig. All right, let's find our u, let's find our dv. Now remember, for u, we want to think what gives us a simpler answer. So if I picked u to be sine 4x, for example, the derivative of sine 4x would be 4 cosine 4x. Is that any simpler than sine of 4x? No, it's not. So I'm going to instead let my u be x squared, and that means du would be 2x dx, and my dv is what is left, sine 4x dx. The antiderivative of sine 4x dx is 1/4, actually negative 1/4, cosine of 4x. All right, ultraviolet voodoo, here we go. So we've got negative x squared cosine 4x divided by 4, I took uv, minus voodoo. So I'm actually going to bring out my constant. So I have 2 times negative 1/4, which would be negative 1/2. So this would actually be plus 1/2 times x cosine 4x dx.